All right, so today we're going to be looking at the power rule and the derivatives of exponential functions, mainly e to the x. This should all be review from last year, so there's more kind of some minor details here and there. And again, I apologize, I'm not able to be with you today. So, one of the first things we want to take note of is that if we're being told to differentiate, we're just being asked to find the derivative. If we are given the notation d dx with a function inside a bracket or parentheses, they're just asking us to find the derivative. One good rule of thumb, and you'll see this in the work that I do and in the homework, is if the problem does not start with an equal sign, it does not end with an equal sign. All right. So probably you remember from last year that if we're given a function like 3x to the fourth plus 7x cubed minus 6x squared plus 5x minus 8, that if we're going to use the power rule, we're going to do 3 times 4 to get 12, and then 4 minus 1 to get 3. 7 times 3 to get 21, 3 minus 1 to get 2. Negative 6 times 2 to get negative 12, 2 minus 1 to get the exponent 1 that we typically don't write. 5 times 1, and then 1 minus 1 gets us x to the 0, again, something we typically don't bother to write. And then the derivative of any number without a variable we know is 0, resulting in our derivative. Notice that I've taken the time to label this as my derivative. That is something I expect you to do. If you are given a function by name, you give its derivative by name. We were given f of x, I expect you to call this f prime of x. And so similarly, if I was given a new function like 6x squared plus 3x minus 9, 2 times 6 would get me 12, 2 minus 1 would get me 1, 3 times 1 would get me 3, 1 minus 1 would leave me with x to the 0. But again, we typically don't bother to write those values in. Now, notice that I labeled it dy dx. I will typically always label it dy dx. If you prefer the y prime notation, that's okay. There will come a time later in the year when dy dx is absolutely necessary, but we're not there yet. So hopefully these two examples have kind of jogged your memory that if we were going to represent our power rule in general, if we had a coefficient a and exponent n, then the derivative would become a times n, x to the n minus 1 power. It leads to those same ideas that if we've got a times just plain old x, x to the first, then we know the derivative is a. And similarly, if we've got a constant or something without a variable, its derivative is 0. Now, really in this section, the only thing that we would want to kind of refresh your memory on is what to do with fractions and what to do with square roots. We can't take the derivative of the fraction until we rewrite it using negative exponents. So for instance, my 1 over x squared becomes x to the negative second. Now, coefficients stay where they are. So in this next one, you'll notice this 3 is in the numerator. So when I go to rewrite, the 3 stays part of the numerator, and I rewrite it as 3x to the negative 4. Similarly, in this third example, my 2/5 x to the 6th, the 2/5 does not change. Only the x moves. Only your variable will move. So only your variable will move. Once we've rewritten using those negative exponents, now we're ready to take the derivative. A common mistake is people rewrite their negative exponent, but then don't take the derivative, thinking they're done. So, for instance, I want the derivative of 6 over x to the 7th, so I rewrite it as 6x to the negative 7th, and then 6 times negative 7 minus 1. Now, if you wanted to take the time to rewrite, you can, but note, again, the only thing that's moving is the variable, similar to what I said above. The only thing that's moving is the variable. Notice the problem did not start with an equal sign. Notice my answer does not end with an equal sign. And so what we start to typically see is problems like f of x is 4x cubed minus 1 over x to the 5th. I need to rewrite that minus 1 over x to the 5th, and now I'm ready to take my derivative. I know my derivative for 4x cubed, 12x squared. My derivative negative x to the negative 5th, negative 1 times negative 5 gets me positive 5. Negative 5 minus 1 gets me that negative 6. And again, whether you rewrite or leave it with the negative exponent, I end up with my final answer. Now, for radicals. When we have to rewrite a radical, we take whatever root we're being asked for, n, make it the denominator of our exponent, whatever is the exponent inside the radical becomes my numerator. So, if I have something like square root of x, I've got a square root, an exponent of 1, gives me an exponent of 1/2. And like with the fractions, once I've rewritten, I haven't taken my derivative yet, I've simply rewritten. So if I've got the cube root of x squared, I can rewrite it as x to the 2/3, and I'd be ready to take the derivative. So let's say we've got a function, y equals 3 over x plus the 5th root of x squared. Both of these need to be rewritten. Notice in the fraction, the only thing that moved was the variable. My 5th root has become the denominator of my exponent. The exponent inside my radical has become the numerator. And now I'm ready to take my derivative. Again, if you like the y prime notation, that's fine. I'll use the dy dx notation most often, but they're pretty much interchangeable until a very specific topic later in the year. So 3 times -1, -1 minus 2, 1 times 2/5, 2/5 minus 1. If you want to leave in this form, that's fine. If you want to take the time to rewrite, that's fine as well. Now, we're going to focus on the exponential function e to the x today. We'll look at the other forms of exponentials next time. But generically, if I've got a coefficient times e to the x, the derivative is just that exact same coefficient times e to the x. So we can quickly see, if I want the derivative of something like -4x cubed plus 7e to the x, I'll use my power rule, -4 times 3. Oh, I've made a mistake. Let me fix it. -4 times 3, and then 3 minus 1. And then the derivative of 7e to the x is just 7e to the x all over again. Similarly, if I've got a function like -6x squared plus 4x minus 3 to e to the x plus 8, I use my power rule to find my derivatives. And then my derivative for -3e to the x is -3e to the x all over again. And then, of course, the derivative of anything without a variable is just 0. Now, like I say, a lot of this stuff should be review, mainly with probably the things that we're focusing on the most being the radicals and the fractions. But we'll just spend a little bit of time practicing the power rule and dive into its uses next time. All right. Again, sorry I couldn't be with you today, but I will see you soon. Have a good day.